Hello and welcome to week 9, and I hope you had a very pleasant break from school. At least maybe it was a really big vacation type thing, or maybe you just had a few things not on your to-do list, but nonetheless, I hope this has been a good week for you, ready to dive back in. Week 9, we have roughly 6 weeks left in this class, and so it's going to be time to be looking at if there's any final projects or anything that kind of looking at you got your midterm grades, kind of getting things all buttoned up so we can have a nice strong end to the class. So in statistics today, we're starting to go, and after looking at all that descriptive statistical tests that we've been doing, we're going to actually this one is sort of on the border. Regressions and correlations are both descriptive, and they're part of the kind of testing that we use to answer hypotheses. Mainly, is there a relationship between any two variables, correlation, and if I know one of those variables, can I successfully and reliably predict the other variable? That would be regression. And so these two kind of go together, and those tests are very, very similar to each other. As we look at correlations are often misunderstood as being an explanation of cause-effect relationships right from the get-go. I hope this is not the first time that you've heard that correlation is not causation. When we see two variables correlated, but there's really no reason why they should be, we call them spurious correlations. They just happen to happen in nature. They happen to happen in our society just by chance. The video at the beginning of this chapter gives some very funny examples of that. So the discussion is go out there and see if you can find some spurious correlations that have been put out there in the media. Let's see how that is going to. I'll tell you one. There's when Donald Trump won the presidency, there were correlations between the votes that he got and the number of middle-aged white men without education that voted. And people saw this as a cause-effect relationship when in fact it was nothing of the kind. There certainly was a much larger percentage of people in that demographic that came out to vote, but that is not the reason why he became president. So that's correlation, not a causation. Now, in the quiz, I'm having you it's a multiple choice quiz about various aspects of correlation and regression. And then in the assignment, I'm having you take a set of data, create a scatter plot, compute the Pearson R correlation, and find the best fit line representing that relationship all in one. So you're going to be doing all of those things and explain those things, how to do that in Excel in the course book. Now I do want to take a little bit of time here to take a look at one of the graphics that I have in the course book. We'll take a look at this right here, and you all recognize this. This is the relationship between temperature and sales at our ice cream shop. And I just want to point out the different kinds of information that are here. So you might notice that these spots right here, each one of these, kind of marking them with red, each one of these, those are the data points that happen. And what they do, what these points are, is when the temperature was here, the sales were here. So that one point represents a data point when there was temperature at a particular place and sales at a particular place. Now, the collection of these dots right here, this is the scatter plot. In addition to computing the scatter plot, you can also have Excel give you the Pearson R correlation, which is that R squared. And this is a 0.90. Well, it says it right there, 0.90 correlation. And so we know that correlations are from -1 to +1. So it's always a point something. 0 meaning no correlation, 0.1 being a low positive correlation, negative 0.1 being a very low negative correlation, and this is a very high 0.9 positive correlation. The final thing that we asked to look at is to compute this particular line. This is the best fit line, or the regression line. And with that comes this formula. Now we can use this formula depending if we know y or if we know x. If we know what temperature it's going to be, for example, along the x-axis, we can plug it into right there and solve for y, which would tell us our sales. And in fact, we could actually start with y, the sales, and predict what we would get in terms of temperature. Now you can see sales doesn't cause temperature, but we can actually solve for that. Now, these numbers that come from that particular, I'm erasing all this here, that come from that particular formula describe the figures along here. This line right here, and it goes forever, like that. So what it's doing is it's calculating to that line. It's not calculating to this original data. That original data is what produced the line, and now we can use the line independent of the actual data to make predictions. That's what regressions are for. We use regression analysis. If we only have part of the data, we can use the information we have from a regression to predict the other variable. So, in this case, if we only knew what temperature it was going to be tomorrow, we could have a rough estimate following this formula as to how much ice cream we're going to sell. So, good luck with that chapter, and I will see you all in the discussion boards.